We are discussing chapter 8, hypothesis testing. Any kind of hypothesis testing, we have to apply 5 steps. So here is the 5 steps, right? Yep. So, so far, we have 2 kinds of hypotheses. Let me summarize the 2 hypotheses. Today we are going to discuss the third one. It's a testing for the proportion, right? Yeah. So let me summarize the 2 testing procedures. The first one was the z-test, and the second one was the t-test, right? So now we have 2 testing procedures, the z-test and the t-test. As not only summarize the chapter 8, but I want to compare to confidence intervals in chapter 7, right? Then I want to start from chapter 6. In chapter 6, we had the sampling distribution for the sample mean. Sampling distribution for a sample mean. Excuse me. X bar. Yeah, we have 2 parts. And now in chapter 6, we had the sampling distribution for the sample mean. It was, and we stated, the sample mean has normal distribution, mean, and the standard deviation. Do you remember? Yeah. In chapter 6, the sampling distribution for the sample mean was normal distribution with the mean of standard deviation in the normal distribution. Based on the sampling distribution, based on the normal distribution, in chapter 7, we made confidence interval for unknown population mean, which was x bar plus n minus z sigma over square root of n. Confidence interval, chapter 7. And now in chapter 8, we got the test statistic. It was a z again. X bar minus mu 0 over sigma over square root of n. So please compare them. In chapter 6, we got the normal distribution for the sampling distribution for the sample mean. And based on the normal distribution, we made the confidence interval, and we determined the test statistic in chapter 8. Good, right? So now here was sigma over square root of n. Sigma over square root of n. Sigma over square root of n. normal distribution. Who was the Z? Standard, the normal distribution, and Z. It's good, right? X bar, X bar, X bar, and X bar. You know, simply, the confidence interval, test statistic, were from the normal distribution. We rearrange, modify, get the confidence interval and the test statistic, right? Yeah. In the t-test, we assume sigma was unknown. So the confidence interval was, using the t-score, estimate the sigma with the s, square root of it. And also the test statistic was t-score, x bar minus mu 0, s over square root of it. We just modify. Simply we just modify the z interval with the t, z test statistic to the t. So even the t-test, t-interval were from the sampling distribution for the sample, right? It's both of them. Both of them were the mean, right? Yeah, they were from the sampling distribution for the sample mean, the normal distribution, with the mean, the standard deviation, right? So please understand the path relationships, right? Yeah. Any question? What did I say? Today's topic. Let me make extend. Okay, just a second. Okay, on the right hand side, today we are going to discuss for a proportion. Today we are going to discuss for a proportion. I'm going to give you a sampling distribution. And let me review confidence interval, chapter 7, confidence interval for the proportion. Proportion, we use the notation of the P. And today, finally, let me give you the test statistic, chapter 8. The test statistic. You understand what we are going to discuss today? Please remind what was the confidence interval first in chapter 7. The confidence interval was P hat, and always we use the z-score times square root of P hat, Q hat over N. Do you remember the confidence interval, chapter 7, right? Okay, then reverse way, let me get the sampling distribution. You know the sampling distribution for who? Please look at this. In chapter 7, we got sampling distribution for a sample mean. Then now what? You know this part for the proportion. So we need the sampling distribution for
A sample proportion.
Sample proportion. Thank you. Yes. We have to determine the sampling distribution for the sample proportion. What will be the notation? P hat. So now I have to state the sampling proportion. The sample proportion has what distribution? What do you expect?
No.
Normal distribution. Why? You know, before, why we use the z-score? Because sample mean had normal distribution. Reverse way, we use the z because he has normal distribution. Yes, it's the same reason. The normal distribution. With a mean standard deviation. In the normal distribution, the mean was the p. Standard deviation was p q over n. So now look at this. Here was the square root of p hat q hat over n. Here is square root of pq over n. And now here is the p hat, p hat, p hat. Normal distribution, z for standard, the normal distribution. Please compare this one, that one, and that one. How do you think? Almost the same. They are almost the same. You know, the right-hand side, it is for the proportion. So here is the, it's a carefully, be careful. Just the P, just the Q, N. But here is the P hat, Q hat over N, right? Yeah. You don't have to memorize. Yeah, we have a cheat sheet. Carefully state just the P, just the Q. P hat, Q hat, right? Yeah. And please compare to here for the mean. Same thing. Exactly same thing. Any question? Okay, today we are going to take the test statistics, right? For the test statistic, chapter 8, today, what do you expect? Is it T-score or Z-score?
Z-score.
It must be the Z-score. See, Z was here and Z was here, right? Yeah, why not? Must be Z. Then the Z must be something minus the other thing divided by the denominator, right? Yeah. So who do you expect first?
P hat.
Thank you. The first one was the X ball. X ball, X ball, X ball. We got P hat, P hat, P hat must be P hat. Same, P hat. But what's the difference? Today we discussed, we made a test statistic for the proportion, P hat. Yes, p hat here. How about the next one? Just a second. The second one, mu 0. The second one was mu 0. Where was the mu 0 from? From the null hypothesis, right? So we stated it's not only the t-test, both the null hypothesis is mu was equal to mu 0. So we just take the mu 0, the initial setting value, is from here to here. You know, today I have to give you the null hypothesis. The null hypothesis will be proportion is equal to initial proportion. Then what do you expect? The second one, P0. Good? So far so good, right? Okay, now, denominator. What do you expect? Who will be in the denominator?
Square root.
We had two kinds of the square root. One has just P, just Q. Second one in the confidence interval, square root of P hat, Q hat over N. What? Sorry, no, it's not P hat.
P.
P, just P, just Q? No, actually. P0, Q0. I'm so sorry. Yeah, it's confused, right? Yeah. It must be P0, Q0 over N. Yeah, for the proportion, yeah, it's always different. The very first, just P, just Q. P hat, Q hat. Now, in chapter 8, it must be P0, Q0. But PQN, 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 right? Yeah. But yeah. So please summarize carefully. Yeah. Case by case. Yeah. Who is the P? Who is the Q? So here is the summarize. Three kinds of yeah, I'm sorry. Yeah. It was the z-test, t-test. Today, we are going to apply another z-test, but for the proportion today. Okay, yeah. So please compare the z-test for proportion and the before, the previous one, another z-test for the mean. Yeah, it's exactly same. The exactly same idea, right? Yeah, we made the confidence interval in chapter 7 and the test statistic in chapter 8, right? Okay, so when I go to the textbook just plug the P and Q. Just P, just Q. But what did I say in the null? P is equal to P0. So it doesn't matter. P or P0, Q0, they will be same. Yeah, because we can take the test statistic under the null hypothesis. In the null, the P and P0 are same. So the left hand side with the P and the right hand side the P0. Now they will be same. Okay. So let me try example. Yeah, look at this. It is an example from the medical field, the eye surgery. Right. First of all, I need the P hat. What was the P hat? Sample proportion. How many samples? How many samples does it have? Huh? 225. we have 225 operations. It is a sample size. And how many patients successfully?
88.
Better, get better. 88. So the proportion, the estimated proportion, the sample proportion must be 88 out of 225. Let me take the fraction. 88 over 225. I have a 0.39. What do I test? What do we want to test? Better. The new method, better than old one. Better. Old one, the old method, it was known 30%. But we are 0.39, 39%. 9% difference. We want to test if the 9% difference is big enough or small enough, right? So that is what we want to test. So in the null, it is for the proportion. So we are going to use the notation, not the mu for the mean, but p equal to compared to 30%. And alternative hypothesis, we want to test better. What does that mean, better? Is it less than 30% or bigger than 30%? It must be bigger than 30%. That means better, right? So now, second step, the z-score was p hat, p0, p0, q0 over n. So now I have to plug, there's a 0.39, 0.30, 0.30, 0.70, sample size 225. So when I take the difference, will be 0.09. Be careful, 0.09, and then square root of 0.3, 0.7, 225. The denominator must be 0.0306. Then when I take the fraction, 0.09 over 0.0306, that will be, we have a z-score. How many decimal places for the z-score? 2 decimal places, always the 2 decimal places, right? So let me take 2.94. It is the test statistic. Next, step 3. I need the p-value. I need the probability. Can I take the p-value from the t-table or z-table? From the z-table. Why? We got the z-score. Yeah. So please look at the z-table from the standard normal distribution z, and the test statistic was 2.94. Can you give me the probability from the z-table at 2.94?
0.9984.
9984. Where it is? Always to the left. Just a second. We stated greater than 30%. Was it left tail? Right tail? It was right tail. Right. What does it mean? We need the probability from the right tail, right? So it's not to the left, but I need the right tail. How can I do? 1 minus 0.9984 will be 0.0016 will be the p-value. Now the p-value is 0.0016 from the test statistic 2.94. How much was the alpha? Alpha was given 1%. Is it less than 1% or bigger than 1%? Less than 1%. Less than the alpha. What was the conclusion? Reject who? HO. Yes. So now step 4. Because p-value less than alpha, which was 1%, then reject HO. Did I give you an example? Yeah. So now, which one? Which one should I take? Reject HO. H. I have to take H. 1. Thank you. H1. Yes. We have to take H1 because we rejected HO. What does it say? H1 bigger than 30%. What does that mean? Bigger than 30%. Better?
Yeah.
Or just to stay worse? Which one? Bigger than 30% means better. Yes. So now I have to make the interpretation. The new method is better than old one. It's good, right? Yeah. So we want to test better than 30%, better. We stated right tail. Take a test statistic, p-value from the right tail, less than alpha, reject the null statement, HO. So we have to interpret H1, bigger than 30%, means better. The new method is better than old one. Any question? It's good? Here's another one. It's another example. It is another example from the agriculture. How many samples? How many samples?
400.
Huh?
400.
400. 400 hybrid seeds, right? And how many germinated?
312.
312, right? But we want to compare to the parents' plants, 80%. You understand what we want to do? What we want to test, right? So let me take the p hat first. The sample proportion. Oh my God. I wanna, just a second, yes, here. Let me take the sample proportion, p hat, from 400 sample and 312 germinated. Then the fraction, the proportion will be 0.78. And I want to test the proportion equal to 80%, 0.8. And what will be alternative hypothesis? What do we want to test? Smaller than, bigger than, or different? Different. Then how can I say not equal to 2t? It must be not equal to different. 80%. Don't forget, take twice because it is a two-tailed. We are going to take twice later to get the p-value, right? Yeah. So now let me take the test statistic, the z. It will be 0.78 minus 0.80 square root of 0.80, 0.20 divided by 400. Then the difference will be negative 0.02. Let me take the square root of 0.8, 0.2, 400. 0.02. Oh, it's very simple. Negative 1. But always the z-score needs 2 decimal places. So I have to say negative 1.0 and 0. You know it is a z-score. So it's absolutely, we need the probability from the z-table, from the standard normal distribution. And we got the negative 1.00. Can you give me the probability from the z-table at negative 1.0 and 0, please? 0.1587. Do I have to do 1 minus? Be careful. We need the two-tailed, right? Always, we have to get the tail probabilities. So we have to take tail, the left tail. It is 0.1587, but we stated it's not equal to. Just simply just take twice. Do not apply 1 minus, but take the left tail, 1 tail, then twice. How much will be the twice? 0.3174 is the p-value. How much was the alpha? 5%. Can you see here? 5%? How do you think? Is the p-value bigger than alpha or smaller than 5%? It is 31%. It's bigger than 5%, right? Then what was the conclusion? No. Give me the conclusion.
Instead of change, we do not reject it.
Do not reject the no. Thank you. Yeah, I want to do step by step. So step 4, because p-value is bigger than alpha, which was 5%. So not to reject HO. Now, not to reject HO. Which one should I take? HO. Then now we do interpret HO. HO said it is 80%. But what was the question? What was the claim? Is different? How do you think? It's not different. Yes. The interpretation must be, how can I say? The population proportion. It's a step 5. The population proportion germinating from the hybrid is not different. Can you make the conclusion? Right? Yeah, I want to make bigger. Yeah, we just deny because we did not reject the HO. So we have to interpret what does it mean HO equal to 80%. That is, it is not different, right? Yeah. So it's almost the same. 5 steps. State hypothesis, test statistic, p-value, true tail, conclusion, interpretation. Okay. Any question? You know, the evaluation is open, right? Did you get the email from school? Right? Yeah, please click the link and please evaluate this course and me. Right? Yeah. And now here is the quiz number 23. Quiz number 23, we want to test decrease. Decrease. Okay? Okay. Anybody who got the p hat? 0 point, 47? Anybody who got 47?
Yeah.
47, thank you. And then the test statistic, okay. We have to compare to equal to 0.55 and decrease less than 0.55. Then now the test statistic must be 0.47 minus 0.55. Square root of is 0.55, 0.45 over 47. The difference will be negative 0.08, and you have to take the square root in the denominator and get the negative test statistic. Then we have to take the p-value from the z-table. We take the negative z-score. And less than 0.55 was left tail. So exactly we need the left tail from the Z table. That will be the p-value. And you have to make the conclusion and interpretation. Do you have an idea? Anybody who got the test statistic, the Z-score? Anybody? Not yet? Say again? Anybody who got the negative 1.19? You got negative 1.10? Negative 1.10? Please using more decimal places. Just a second, let me take the denominator, square root of 0.55, 0.45. I think because of the rounding problem. So let me take, let me see. The denominator must be 0.07, 2, 5, and 7. Okay? Let me take the more decimal places in the denominator. Then negative 0.08 divided by 0.07257. I have a negative 1.10. Yeah, I have a negative 1.102, right? Yeah, but we need the 2 decimal places. So let me take off. It's a negative 1.10. Then anybody who got the probability at negative 1.10, please? Negative 1.10. 0.1357 at negative 1.10, negative 1. Do I have to take twice? No, it was the left tail, so it is the p-value. Directly, it is the p-value. How do you think? How much was the alpha? Where is alpha? Alpha was there, 5%. Is it bigger than 5%? Less than 5%? Bigger. What was the conclusion? No, not to reject. So I have to say, because p-value is bigger than alpha, which was 5%, so not to reject the null hypothesis. Which one should I take? HO, H1, which one? HO. It said it is 55%. How do you think? Decreased? No. How can I say? Blah, blah, blah. Has not decreased from 55%. Has not decreased because we didn't reject the null. Does it make sense? Right? Yeah.